Hey guys, welcome to Unit 7, Lesson 7, Molarity Practice. Today I'll go through some of the practice packet problems to help you understand it. Please watch the video as a tool, so maybe skip around to problems you don't understand. I'll try to label those. Alright, let's get started. Alright, yep, should be good. Well, remember our homework is page 19 to 23. So let's look at page 19 in our practice packet, do a couple of these problems. The first question is, what is molarity? And I will try to do them up in the margin so you can see. I'll use a pen today. What is the molarity of the solution that contains 20 grams of this and 0.5 liters of solution? The first thing we need to do is understand molarity is equal to the number of moles over a liter. And we have the liter data, but we have grams instead of moles, so we need to convert grams to moles. And in this case, we have 20 grams, and we need to calculate the molar mass of calcium bromine, or bromide. So make sure you remember how to look up the molar masses of each of these elements. So we just take a look at calcium, which is right here, and I'll try to make that flat. So that's about 40. Plus 2 bromines, and that's about 80. Because there's 2 of them, so that's 160 plus 40, which is 200. So there's 200 grams per mole. So you'll notice we're going to have to divide by 200 to get the number of moles. And I'll try to do every step on this problem. So, just in case someone has trouble, we're going to take 20 divided by 200 grams per mole. And that gives us 0.1 moles. Now go back to this formula. Molarity equals, if we have 0.1 moles over, it looks like we have a half of a liter. We take that 0.1 and divide it by half. And we get 0.2 molarity. Alright, let's move on to another one. Alright, I'll probably assign even, so I'll do evens from now on. Let's go down to 32. I'll just briefly talk about 30. What is molarity solution is 0.5 moles of, this is nice because they already give you the term in moles, so you just take 0.5 moles divided by 0.5, and that will equal 1 molarity. Alright, number 32. If 0.25 grams of lead nitrate is dissolved in 100 grams of water, what is the concentration of the resulting solution in parts per million? So don't forget the parts per million formula is on the back of the reference table. You do the part over the whole times 1 million. So that's a relatively large number to multiply, but we'll see we get a small number to begin with. So we need to figure out the molar mass. Oh no, we don't need to do anything. We have our 0.025. We need to divide a part that's lead nitrate dissolved in 100 grams of water. And so that will be 100. Now to be exactly right, we would have to take the solution's new mass, which is 100.025, because we add a little bit of mole. And then we're going to have to multiply by 1 million. To 0.025 divided by 100.025. And we get we actually get this number, but that's not the final answer because we have to multiply by 1 million, which is 10 to the 6th. If you don't, you can simply write out the numbers, we get 249.9 parts per million. So I hope that helps with that one. Number 34, 20 milliliter sample of 6 molar HCl is dilated with water to a volume of 40 milliliters. What is the new concentration of the solution? I taught you a formula yesterday in class, which is the concentration of the initial times the volume of the initial must be the concentration of the second times the volume of the second. Now using this formula I think helps us. I'll zoom in a little bit. Did I zoom in? I don't know. Let's try that again. Yeah, that's really good. All right, so we just take the 20 milliliter. Oh, we have to convert this to liters. So 20 milliliters is actually 0.02 liters, and 40 milliliters equals 0.04 liters. So when I plug those in, I just need you to know where I'm getting these numbers from. Concentration is 0.6. The volume is 0.02 equals a new volume of 0.04. Sorry, I'm running out of room there. So hopefully to clarify, I don't know if this can clear up the screen at all. Oh, that's much better. Yeah, I'm trying to get everything in there. I don't know if that's going to work or not. 0.6 times 0.02 divided by 0.06. Wait, did I do that right? I think I got everything right. I don't know why I wrote 0.06. It should be 0.04. Sorry about that. I do know right because I wrote it really small. I misread my handwriting. If you didn't catch on, what I didn't do is I should write 0.04 liters. All right, that's better. We got 0.3 molarity. Okay. Oh, if you didn't catch on what I did, I just made that little mistake where there I put 0.06 instead of 0.04. All right, gosh, I don't want to do all of them. I guess it would be nice, but I'll do whatever ones you guys want in class, you know, when I see you on Monday. Let's try this one. It's not too hard on the next page. What is the molarity of a solution that contains 0.40 moles of KBr in a 0.5 liter? I don't think this is very bad. And this goes back to our molarity equation. This is on the back of a reference table, moles per liter. So it's 0.4 moles over 0.5, and that's it. And sorry, I should get my calculator again. That equals 0.8 molarity. I really should use significant digit. You'd write it 0.080 molarity, and that is the correct answer. All right, number 2. These are not moles. we need to do the molar mass of ammonia chloride. And so really quick, we go back to finding how much the molar mass of ammonium chloride is in nitrogen is 14, hydrogens, 4 of them are 4, and chlorine is 35. So when I do that, that gets me the molar mass, which is 14 plus 4 plus 35. Just to be exact, I'm going to put all those digits in. And that's how many grams there are per mole. There's 53 grams per mole. So if I'm going from grams to moles, I divide by the molar mass. So I have to take 65 and divide by 53. So now we take the 65 that we started with, 0.1, divide it by the molar mass, and we get 1.21 moles over 3.5 liters, and that should equal 0.348. Now, why do I get that in molarity? That's our final answer. Because over here we have 3 significant digits, and here 3 significant digits, so we have 1, 2, 3 significant digits in our answer. All right, that's the difficult one on that page. And I'll tell you what, I don't mind these problems at all. I don't think you will either. It just needs practice, because there's a lot you learn this unit. Try one. Let me try number 12. If a solution has a molarity of 5 moles, how many moles are present in 5 milliliters? All right, so this one I'm going to use C1. Hold on, let's see what we got here. We have molarity, right? That's a concentration. And we have 5 milliliters. So here's the idea. I'm going to say this is 5 moles over 1 liter. And then what if we don't have a liter, but now we have, what is this in liters? So we divide by 1,000. So what if we have 0.005 liters? How many moles are present there? And so by doing that, we just multiply 5 times, where's my calculator? Oh, I can do that too, a little tricky method. So it's 0.025 moles. That one's a little tricky, I guess. Okay, remember we're moving all the way to 22, so let's look over here, any tricky ones. I don't know if they're tricky or not. Oh yeah, this is an interesting one. A sample of sewer water has 6 milligrams of mercury and 200 grams of water. What is the concentration in parts per million? So remember, it's parts over whole, but then instead of like a percent where you multiply by 100, you multiply by 1,000,000. So we have 6 milligrams, and 200 grams of water. So here's the problem. These aren't the same units, so I'm going to make them into the same units. And if you recall, it doesn't matter which one I change, we just need to make sure they're the same. And so I probably will change this one to be smaller. I'm going to change it both to grams. So 0.006 grams. I divide that by 1,000. Tenths, hundredths, thousandths, 6,000ths of a gram. And that's divided by 200. And then don't worry, it's going to be a small number, but we multiply it by 1,000,000. So it's 0.006 divided by 200. And then I multiply by 1,000,000, which is the same thing as 10 to the 6th, you know, because 1,000,000 has 30 numbers, and it's 30 ppm. Okay, what problem was that, number 3, next page, okay. That, I think, covers most of the type of problems you'll see in the homework. Feel free to watch the video and go to the parts you want. Thanks for watching, guys. I hope it works.